Hey guys, and welcome to the start of week 9. We're going to go over 2 chapters in the book, which are chapters 13 and 14. And basically, I know this is it's probably going to be a lot of content for this week. I want to make sure that we're still on track to cover everything we need to for the semester. Obviously, next week is spring break, and there will be no content for next week. So that to be said, what we're going to go over today, we're going to start with views and then move on to some other content. So what is a view? I'm sure you guys have heard me talk about view or views, and what a view is really is it's just a select statement that's been stored within a database. And so really what this is, it's basically a shortcut for a select statement, right? So if I have a view and I opt to, if I have a view, instead of having to type out my entire select statement, I can just call the view and access it that way. So basically, you can almost think of a view as a virtual table, and that virtual table only contains the rows and columns specified in the create view statement law, which we're going to go over here in just a second. And basically, the way we create a view is through the create. Yeah, I'm not going to link my phone. Is through the create view statement, right? And so create view looks something like this. Create view. Let's do this. Let's find some data. Select. Okay, so let's do this. Basically, we do create view orders from Hanar, and then we plug in our select statement, or I'm sorry, create view orders from Hanar as select all from orders where customer ID equals Hanar, and we run that. So now we've created a view orders from Hanar. And so now, instead of having to run this SQL right here, now I can just run select star from orders from Hanar. And so now you can see I've pulled back all of the data from this view. Now, the other thing that you might be curious about is, let's say that I change something inside of, let's say I change some data inside of here, right? Or inside of the Hanar orders. Say that I update let's do this. Let's update orders, set ship name equal to Ari Carnes. Ah, shoot. I didn't mean to do that. Well, can I undo? I may have just really screwed up. Let's see. Ah, crap. Okay, I should be able to fix this. I won't worry about it for now. Okay, so as you can see, now I've updated every order to reflect the ship name, which totally kind of defeats the purpose. I'll fix it later. I can just restore from backup. But now what I can do is if I run my view here, now you can see the data has been updated to reflect the changes in the original table. And that's true if I have a view that's doing a join as well. And the same goes for deletes or inserts. So if we added new orders from Hanar, our view would reflect this. And so basically, we can use views to benefit us in a few ways. The data in the first way being, we can access data and it's not dependent on the structure of the database, i.e. we can do joins and things like that. And for the users that are using the views, they don't have to be concerned about the structure of the database so much as just accessing the views. We can also restrict access to the data in the database by only allowing certain users to access certain views, which we'll get into all that later when we go over database security. Obviously, we can be flexible with our views, i.e. creating views to accommodate different needs or different things that we need to see. We can also simplify our queries, right? So if I wanted to do a massive join and add a bunch of conditions, or if I wanted to do, maybe roll-ups or aggregate functions, instead of having to type out these massive queries, I type them every time I wanted to use it. I could type them once and use a view to pull that data back. Now, there are obviously some options that we can take when creating our views. And we can do, basically what this looks like is, let me see. And so what these options look like is we'll add a width, and then we can do either encryption or schema binding, or we can combine these, or let me see. We could do a check option, and these add some restrictions to our views, and I'm going to go over these here as soon as I take another drink of my beverage. Okay. The encryption part of the clause keeps users from examining the SQL code that defines the view, and so basically this prevents users from being able to see what SQL we're actually running to pull back this data, i.e. the users can see this via inet, but they can't see this. The schema binding basically binds a view to the database schema, which means I can't drop tables in the schema in which the view is based or modify tables in a way that would affect the view. So if I'm creating a view that's being used by maybe an application, and I want to ensure that the database doesn't change in a way such that the view no longer works, or as it will break the application, or I don't want to drop tables, I would do schema binding. And then the last thing is the check option, which prevents a row from being updated through a view if it would no longer be included in the view, i.e. If I create a view with maybe VI-net orders and there was a mistake in the orders table and the VI order was actually a Hanara order, the check option prevents that update from being made in the orders table. Let me see. Now, that's not to say that views are immutable, right? And what I mean by immutable is that we can't change them. We can also create updatable views. And this allows us to refer to it in an insert, update, or delete way to modify an underlying table. And there are a few requirements that we have to apply in order to create an updatable view. And basically the first is that the select list when we create our view can't include distinct or top clauses, it can't include aggregate functions, and it can't include calculated columns. We also can't include a group by or having clause, and two select statements can't be joined by a union operation. And basically, this really limits what we can do with the view. We basically have to do something like what we've got here. But by creating views that we can update, this allows maybe application code to access a table or update rows in a table without having to write advanced SQL queries, for example. That to be said, generally speaking, using update, insert, and delete statements to update data through views is kind of inflexible and prone to errors, and we should probably avoid this technique. Really, the better way to do this is through triggers, and we will go over triggers in what chapter? We're in chapter 13. We'll probably go over triggers after spring break. But what we can do is we'll go ahead and create this VI-net view as, okay, so now we've created our view. So you can see we've got our VI-net orders right here, right? And so let's take order ID 10739. And so now, since I don't have any of the constraints that I listed, now I can do delete from orders from VI-net, where, if I can type today, whoops, where order ID equals 10739. Okay, so we have a conflict. Let's do a better example of this. Okay, yeah, let's do. If I can remember how to do an insert statement. Oh, why am I blanking on this? Well, that's right, but insert into. Ah, okay, I see what I'm doing wrong. Whoops. Insert into shippers. Oh. I am really off my game today. Oh, wow. Okay. Okay, let's do this. All right, that was a real pain. Okay. Okay, so now we're back to where we're going to do. So we'll do create view, shippers view as select star from shippers, run it. Okay, so now as we can see, so we've created a view, select star from shippers view. Let's make sure we're still recording here. Okay, cool, we are. And we run it, so now we have 4 shippers. So what I can do now is delete from shippers view where company name is equal to FedEx. So now if I do a select all on shippers, that company is gone from shippers. And if I select again from shippers view, company is gone from shippers again. Or it's gone from the shippers view. So now if I run another insert and add that value back, we can do an update statement, right? So now we have another one, or now we have another shipper, and we can do now an update using a view. So update shippers view set company name equal to Federal Express where shipper ID equals 5. So I've run an update statement, and now I can do my select all from shippers view again, and now I have Federal Express. And then if I want to delete or modify a view, there's a few steps we can take. So to drop a view, what I can do is I can just run drop view VINet or orders from, if I can spell orders from VINet. So now my view VINet is gone. So I can also alter a view using a similar statement or using a similar alter statement to what we use to alter data in a column as well. And that looks like this. Alter view, shippers view as select star from shippers where name company name like Fed. So now if I run this view again, you can see now I've only got 2 because now I'm only getting the ones that have Fed in the name. So we've gone over updates, we've gone over insertions and deletions. And I think that pretty much covers views. We're not going to get, I don't want to get too in-depth with the views, but I do want to cover them just a little bit. So on to our next topic, which is coding scripts. And so most of the scripts that we've worked with so far consist of a single SQL statement, right? So a select all, update, delete, etc. However, scripts can include a number of statements, and these statements can be divided into batches, and we can basically, and we'll go over batches here in a second, we can also create databases and create tables and insert data, all using scripts. And so let's code up a basic script. And so what really all a script is a number of it's a number of statements run. It's a number of SQL statements as a single SQL statement, right? And so let's code up a basic one. So let's code this up and then we'll talk about it. So create database testDB, go. Create table test table1, test ID int not. Let's do this. Test ID int not null. Identity primary key test val1 the varchar. And so basically what this script does, and we could store this in a file, and basically what this script does is this creates the database testDB. Whoops, I forgot one statement, use testDB. And so basically each script can contain one or more batches that are executed as a unit. And what this means is that this is going to be created first, or this is going to be run first before any of this. And the reason we have this as a single batch is because if we try to run this before this is created, then this will fail. And so now if we run this, and then we reconnect. You can see we've got our test DB, we've got our tables, and all of that, which is exactly what we wanted. Now, the other thing is that, say we wanted to create, let's see, let's actually insert, let's delete this and run this again. Why did I do this? Drop failed your database. All right. Let's Control C, use Northwind, drop. Okay, so now if I refresh, if I connect it, okay, so now we're gone. All right, now we're good. Okay. So let's go ahead and insert some data to insert into and the reason I'm doing this is the reason I'm adding data first is in order to create a view, a procedure, a function, a trigger, or a schema, we must include these in their own separate batches, right? And so I'm just breaking these statements down into batches so that I can come down here and do a create view test table to view as select star from test table to go. So now I've run my script, and if I comment all of this out, and I do use test DB select star from test table to view. Now you can see I have I've selected from my view. So I created the tables, I inserted the data, and I created a view, and now I can pull from the view. So that to be said, we just want to make sure that we're including them in batches. So we can include one statement in a batch, or we can include multiple statements in a batch. We just have to make sure that our views and our procedures and our functions and our triggers are in their, and our schema creation is in its own view, or in its own batch, not view. So there's also, so now that we have the basics of scripting down, there is also something that we can use called transact SQL, or not transact SQL, but there are transact SQL statements that we can use to process scripts, and these are sometimes called T-SQL statements. And basically, there are several of them, and basically there's if else, begin, end, while, break, not debreak, break, continue, try, catch, go to, return. And then there's also use, and these are really just keywords for controlling execution, right? So use, print, declare, set, exec. And we're going to go over each of these real quick. So if else controls, it's a conditional, right? And so basically, this is just like in a in code, right? So an if this then that type statement. Begin, end, it defines a statement block, and we'll cover that here in a second. At least I think the book goes to it. The while loop repeats a statement until a specific condition is true. Break exits the innermost while loop, or breaks out of a while loop. Continue returns to beginning of a while loop. Try catch controls the flow of execution when an error occurs. Go to unconditionally changes the flow of execution, and return exits unconditionally. And then use changes the database context to a specified database. Print prints a message to the client. Declare declares a local variable. Set sets the value of a local variable or session variable. And exe or exec executes a dynamic SQL statement or stored procedure. And so let's code up a couple of, let's code up an example of this using, or let's code up some examples using some of these things. All right, so let's see here. Okay, so we have, let's do use if exists let's do this. SQL Server. Better yet, let's do this, because this will be a little bit more effective. If count actually, let's do this. Set or declare okay, so here's one. Okay, so if at test table rows greater than 0, actually we'll say less than 1, okay, let's see if this runs. All right. Okay. So the book has a really bad example of this. So let me see here. else do we need to cover here? We're not going to do while break or continue. Try. I'm just coding up all the examples here, and then we'll talk about them. Oh, SQL Views. Okay, I'm doing this way wrong. We'll go over exactly later. Okay, so let's go over what we've got here. All right, so we create the database testDB, we use it, we create a table, we declare test table rows as an int, we set the value of that using the select count from test table 1. If that value is less than 1, go to insert test table 1 data, which we've defined right here. Otherwise, go to create test table 2, which we've defined here. Here, we are creating our test table, inserting data, and then we do a try catch, and we attempt to insert bad values into test table 2, and if it fails, we print cannot insert string into float column. So now that we have our script, we just need to delete the table. So now we should be able to run this. Okay, so we've got no red lines, we'll run it. So everything ran right. You could see we outputted here. And actually, we'll run this one more time just to get a little bit more haptic, or a little bit more feedback. Print. So if you guys recall, we can also concatenate. So I'll say Okay, so we've redropped our table again. Line 67. How do I view my numbers? Oh, okay, I see the problem. Yeah, so I can't do a subquery here. But what I can do is declare I can do set test table rows equal to select count from test. All right, we're going to try it again. Okay, so the problem is that in these prints, we can't run a SQL state. We can't run a select like a standard SQL query. We just can run these functions. Okay, so you can see our output. So no data in test table, inserting data. Data inserted successfully. The number of rows is the number of rows here. Creating test table 2, and we've moved on. Our try catch fail, or we do our try, it fails. We go to the catch, and we move on. Okay, so let's see, we've gone over that. All right, guys. I gotta pause here. I think I need to let the dog out, so I'm gonna pause here and then pick it back up in a second.